Okay, today we will cover an introduction to classification. This is called binary and multi-class classification. So like we mentioned in week 1, there are three types of machine learning. So we have covered unsupervised. Unsupervised include clustering, and we also have covered supervised, which is the regression. So another type of supervised learning, this is called classification. So today we will look into classification. Okay. So for the supervised machine learning, we can have regression if your dependent variable is continuous variable. Okay. So if the feature that you want to forecast is numerical values, then you can consider regression. Okay. But if your dependent variable is categorical value or label, then we call it classification. Okay, so today we will learn more about classification. So we will need to define what is a model, or how do we train them, and then how do we test them. So that one we will go through next session. So the idea is, when we have data, so we want to perform classification for the dependent variable, we need to train the model first using the train data. So once we have model data, then we can test to evaluate the performance of the classifier. Okay. So for example, we are trying to classify a family car. So if you want to predict whether that particular car is a family car or not a family car, so we need to define some of the features that we can have. For example, we are looking at the price and also the engine power. And then the output could be positive or negative. Positive means the car is a family car. Negative example will be those cars which are not family car. Okay, so what we have here is that we have X and Y. So X is the price and Y is the engine. Okay, so and what we found, this is based on what we have in our sample data. All the positive are around here. So that means the range of family car is around here, the range of price, and also the uh, range of engine power is around here. Okay, so around here. So this is in the 2D space. So we can say that, okay, how do I draw this line to separate them in order for me to classify them? So over here we have n tuple. So that means how many we have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 negative and 5 positive. So basically our n here is 15. Okay, and each x will have their own class. Okay, so the class will be 1 if x is positive, 0 if x is negative. Okay, so each of the individual item will be represented as two items, x1 and x2, which is the price and also the engine power. So when we talk about this, when we train the model or when we modeling our data, we actually trying to estimate the line that separate the positive and negative. Okay, for example, like this, we are trying to maximize the area cover for the positive and also area cover by negative. So when we perform training, basically we are trying to estimate the line here that separate the positive and negative. Okay? And let's suppose this is the actual area that cover the positive, but when we perform the modeling, the yellow one is what the model trying to say. They said, okay, based on this, the hypothesis for class H is around the yellow one, okay, the yellow boxes. So the hypothesis said that is one if H say X is positive. So that means if you are saying that, okay, if you can see that there is miss or overestimate here. So if, let's suppose the hypothesis say here is positive, okay, here is positive, but actually they are outside the blue box, okay, outside the blue box. So that is what we call false positive, okay, because according to the hypothesis, whatever inside the yellow is considered positive. But when you compare to the actual box, which is the blue one, if the positive is here, so this is what we call false positive. Okay, positive, which is predicted wrong in this case. Okay? But when you are here, negative, because this is outside the yellow box. So based on the yellow box hypothesis, this point is negative. But when you compare to the actual one, which is the blue one, so this is what we call a false negative. Negative sample which is predicted wrongly. Okay, so in order for us to compute the accuracy is we need to know, let me erase this first. We need to know how many of the sample fall within this area. Because this area is false negative and this area is false positive. Okay, so this one will give you the error. So what you need to do is you need to count how many of the hypothesis that does not match the actual one. So this is just accumulation of number of sample that falls in this region. Okay, so the idea is the yellow box must match the blue box in order to get high accuracy. Okay, so for example, this one, the actual box is the blue one, which is this one. So the most general hypothesis should cover at least bigger than the actual one. So this is what we call the between the S and H. Sorry. So this area is the hypothesis. The H belong to the capital H, which is the general hypothesis is between S and G. So this is the minimum size that cover the positive, and this one is the maximum size that cover not the area that include negative. So what it means that I I want to cover as many possible area here from the S to the G. The G is this one lah. Okay. So the C is the area that consisting the Boson space that we have. Okay. So here what we want to do is we want to maximize between the S and the G. So this is the area of hypothesis. So when we train the model, basically they are trying to maximize the area of the hypothesis so that it will reduce the number of incorrect classification. Okay. So these are some of the example. Next session we will learn about logistic regression. So these are some of the what we call binary classification. Binary referring to only two classes. So we have positive and negative. So if we have more than two, that is what we call multi-class classification. Okay. So for example, like this, on your left-hand side is binary classification because we only have two classes. On your right-hand side will be your multi-class because we have more than two classes to model. Okay. So what is multi-class classification? So any input or any sample can belong to one of the K classes. So K is greater than 2. Okay. K is number of classes. So the training data that you get will be input associated with class label. So a number from 1 to K. Okay, so your class label is 1, 2, 3 up to K. Okay. So what you want to produce is, given the new input, you want to predict they belong to which label here. Okay. So each input must belong to exactly one class, not more, not less. Otherwise, the problem is not called multi-class classification. They are sometimes they call it multi-label classification, in which one item can have more than one label. So this is the label. So label 1, label 2, and so on. Okay. So example of application like input handwritten character. So the output will be which character. So this is multi-class because we have more than two classes. Okay. We could also have this input of image. So this is also multi-class because we have more than two classes: car tire, duck, and laptop. Okay. For news article, the output, which section of the newspaper should it belong? So it could be on technology, economy, okay, or sports, and so on. So we try to predict the label of the article based on the content. Similar to the email, we're trying to look at the content and predict which folder we should put them in. Okay. And we could also have input of audio command. So we depends on the sound or the way we pronounce or the way we convert them into features readable by the machine learning. We will look into what action should we take, like close the door or close the window or open the light, switch on the light, switch off the light, and so on. Okay, so the basic thing about classification is we need to know how binary classification is done, and based on the performance or based on the approach for the binary classification, then we can extend to multi-class. Okay, so how do we perform this? We have two methods. One is called one versus all, and the other one is one versus one. Okay, so if we look at this diagram, so over here we have three classes, right? So three classes. So we have so the label here will depends on either they belong to each one of the class here. Okay, so n here refer to n number of sample that we have. So over here we have this is 6, this is 4, 8, this is 7. So we have around 21. So our n here is 21. Okay. So it says that for each of the item that we have, there is a label. Okay. The label here, because over here we have three, right? Three labels. So our K here is 3. Okay. So over here it refer to what class they belong to. So the I here ranging from 1 to 3. Okay. So this one refer to here if this is if that tuple belong to class 1, then they become 1 lah. Okay, so the I is coming from 1 to 3. So the hypothesis that we try to do here is that we want to draw a line that will not have any overlapping. For example, here we have overlapping. This one is a problem because if you have some item here, for example, you have this one, so you will have multi-label, belong to yellow and also belong to the green one. So when we try to model the data, we do not want to have this overlapping. Okay. Okay. So for the first one, one versus one. So the idea is we do not want to have the overlapping. So one versus all means you take one class and then you separate the others. Okay. So for example, like this, first we take the triangle one. So we draw a line there, and then the rectangle, and then the times. Okay. So this one is from multi, and we try to use the binary classification. So from here, then when we continue, go back here. So basically, we are drawing a line that will separate them. Okay. So basically, for us to model this one, we need to have 3 models because we have 3 classes. So we need to have 3 lines to separate them, and that's why they call for 3 classes we need to have 3 models. Okay. So this is how they are translated. So for example, if you have all these features x1, x2, and so on, so this is the green one. So over here we have multi-class. So what happens is that since we have multi-class here, so if we take the class is the green, so this is positive, and the rest which are not green will be turned to negative. So you will have only 2 labels here. Over here we have 3. Okay, so that's why that's how we convert the multi-class to binary. So for this one, we will do it for the green, and then we will do it for the blue, and then we do it for the red. Okay, so this is for the red and blue. Okay, so for each one of these, we need to create the model, learn this model 1 and 2 and 3. Okay, but of course, during the practical, you will not see this thing happen because when you apply, they will show you the result only. So, but actually, this is what happening behind the scene. Okay, so since we have 3 models just now, so we need to 1, 2, and we have 3 just now. So we need to combine all this to become a single classifier. So we will divide the data into training, and then we feed into the classifier. So in this previous example, we have 3 data set, right? So this one will be 3. Okay. So all these things will be combined. So this one, if that particular record belong to class 1, this is 1, this is 0, this is 0. So over here, whichever have the maximum value. So in this example, we have class 1. So this one will be class 1. Okay. So it will take the symbol here, whoever got the maximum. Okay. So that's how we perform the multi-class using the binary approach using one versus all. Okay, but there is a problem here. When you try to perform this, no, we still trying to visualize the line here. So this is for the blue one, this is for the red one, and this is for the green one. So this is no problem. Okay, so we will have 3 model to perform classification for 3 classes. But we will have problem when we have this. Okay, so this one we have what? If we try to perform using the one versus all, we will not be able to see this black one, this one. We have problem. The blue one, no problem. The orange one or red one, no problem. The green one, no problem. But this one, we have problem. Okay, so they have introduced another one. So instead of using one versus all, they propose to use one versus one. Okay, so what happened in one versus one? So in one versus one classification for the n class instant dataset, we must generate this number of model. So for example, in this example, how many classes we have? So n is 4. So if we use this formula, so this is 4 times 3 divided by 2. So basically we need 6, right? So how do we get this 6? Okay, let's do this one. Okay, for example, like this. This is 1 versus 1. So n is 3. Okay? So we should have 3 times 2 divided by 2. So we should have 3 number of model. So what happened here is that, okay, we take the blue one. So we do this one first. Then we get this. And then we take this. We get this one. And then lastly, we get this one for this one. Okay. So we have 3 model here. So this is no problem because we able to draw the line. Okay. But for this one. Okay. For this one, how do we perform this? So we're supposed to get how many model here? Let me. So if we repeat again, we should have, since we have 4 classes here, so we should have 4 times 3 divided by 2. So this is 6. Okay. So for this one, 4 classes, we should have 6 models. So how do we get the 6 model? Okay. So the first one, what we need to do is, okay, we take that one. That is the first model. We will split them. Okay. And then the second one will be this one, and let me use different color. So this one again. Okay. So we can draw the line here to separate them. That is number 2. Okay, and maybe I can use different color again. The red. So this is this one. So we can draw the line here. Okay, so 3. And what else? So we have this, and that. So we need to take in between again. So we have light green. So between this and this one. So we draw line again. Okay. Then after that, we do again for the other 2. So the other 2 will have this. So this guy with this guy. So we can draw a line there, and finally this one. Okay. Okay. So to make it clear, let me modify the slide. So let me modify the slide here. Okay. So can you see this slide? Boleh? So since we have 4 classes here, so we should have 6 model. So the first thing that we need to do is we need to do this one, and then this one, and then this one, and then this. Then the last one will be this. Okay. So by having this, we can have a line here that will separate them. So this one. Okay. So we have six model here. Okay. So So if we have 6 model here, so we can combine all of the model. So we follow what the diagram that we have before here. So we will have six diagram here. This one. Okay, so we will have 6 model combined all here. Okay, so whichever model that can produce the maximum value here, which is 1, so the rest is 0. So the label will be taken as the predicted label that we have. Okay, so any question? Okay, so these are the popular algorithm used for multi-class like KNN. We will study that one. Decision tree, yes, we're going to study that one. Naive bias, yes, and also we have random forest. So random forest is designed based on this decision tree, and then gradient boosting. We will learn this one in ensemble. So these are the multi-class classifier. Of course, we have many, like deep learning also can be used in order to classify multi-class data. And in conclusion, the idea of classifying k number of classes, we can use the one versus all or one versus one. So it is challenging to deal with large data set having many number of classes instant. So we will use one versus one. Okay. So I think that's all for today. Basically, this is the introduction of the classification. So you have the idea what we're trying to achieve in such a way that the hypothesis, which is generated by the model, will match the actual box that we're trying to achieve here. So, for example, the yellow one is the hypothesis generated by the model. Hypothesis is assumption that made by the model. Okay, based on the feature that you feed, then they will draw this yellow line. The blue box is the actual area that we're trying to cover. So if you have mismatch in this area, then you will get the error. So like I mentioned just now, these are the errors that we should try to avoid. So this is positive, false positive. This is false negative. Okay. So we will use this term later on when we want to evaluate the model of the um, uh, after we perform the data modeling. So we want to evaluate how accurate is the model. So we will use false positive and false negative to quantify the quality of the model that we have. Okay. So any question? If you're okay, can you type number 3? Okay. So we have 38 students at the moment.